While Western military analysts obsessed over whether Ukraine could survive another year, Ukrainian engineers were quietly building something that would make even NATO strategists nervous. The weapons Ukraine is rolling out for 2026 fall into 5 game-changing categories: interceptor drones that hunt other drones, armed ground robots that fight without human soldiers present, indigenous long-range missiles that can strike over 600 miles into Russian territory, laser weapons that shoot down threats with the cost of a cup of coffee, and AI-powered swarms that think for themselves. So let's break down exactly what's coming, why it matters, and why Russia's generals are losing sleep. Number 1. Interceptor drones. In October 2025, Ukrainian President Volodymyr Zelensky announced that interceptor drones were achieving a 68% success rate against Russian Shaheds. This was more than just a useful statistic. It was a declaration that Ukraine had practically solved one of modern warfare's most expensive problems. The principle here lies in economics rather than armaments. A single surface-to-air missile costs upward of $3 million, while the Shahed drone it's shooting down costs Russia about $50,000. For reference, Russia is estimated to be able to produce over 2,500 Shahed-type drones per month. Translate that to multi-million-dollar missile requirements, and suddenly you have a few $billion per month gone. It's a smaller country's entire budget, wasted on just one small portion of the enemy's attack operations. The Skyfall P-1 Sun is Ukraine's latest cutting-edge product in this field. With its modular 3D printed airframe, Skyfall is churning out thousands of these drones per month from its production facilities. The P-1 Sun is technically primarily designed to destroy Shaheds and Gerons. However, if given proper armaments and guidance systems, it can target helicopters, giving it multi-role capabilities that justify its development costs. During its debut at the Dubai Air Show in November 2025, Bloomberg footage showed P-1 Sun drones destroying Gerons in live tests. But Skyfall isn't alone in this fight. TAF Industries has transformed from a charity fund assembling drone parts in 2023 to Ukraine's largest scale drone manufacturer, producing up to 80,000 FPV drones per month, with a total output valued at over $1 billion annually. Out of that massive production capacity, TAF now manufactures dedicated interceptor variants alongside its strike and reconnaissance platforms, giving Ukraine the volume it desperately needs. Similarly, General Cherry's Bullet interceptor drone successfully passed government codification in 2025, becoming officially approved for armed forces use. This bureaucratic milestone matters because it opens procurement pipelines, since Ukraine was pushing to field 1,000 interceptor drones daily by the end of 2025, a number that will scale into 2026. The interceptor doctrine is elegantly simple. These drones use visual targeting and terminal guidance to literally ram into or detonate near incoming threats. Unlike anti-drone rifles that require line of sight and drain batteries, interceptors can hunt autonomously using onboard AI for initial target detection, then hand control to human operators for final engagement. The strategic implications are staggering. By late 2025, Russia had launched approximately 1,300 drones per night. Traditional air defense can't sustain that tempo, as the ammunition cost alone would bankrupt Ukraine's defense budget within months. Interceptor drones costing $3,000 to $5,000 each suddenly make economic sense, especially when you're shooting down targets worth less than what you're firing. Number 2. Strike unmanned ground vehicles. The first confirmed Ukrainian ground robot kill happened so quietly that most analysts missed it. On December 10, 2025, Ukraine's 5th Kyiv Assault Brigade deployed a droid TW-12.7 unmanned ground vehicle armed with a 12.7mm machine gun near Konstantinovka. A Russian MT-LB armored personnel carrier rolled into the UGV's pre-established kill zone, carrying an assault team meant to breach Ukrainian positions. The tracked robot opened fire with short, controlled bursts that punched through the MT-LB piece side armor, striking both crew and infantry. The damaged vehicle lost steering control and rolled within centimeters of the small robot before being finished off with additional fire into the rear troop compartment. No Ukrainian soldiers were exposed to direct fire, and the assault was thwarted before it began. For the first time, an armed ground robot had independently held a defensive position and destroyed an enemy armored vehicle in combat. It wouldn't be the last. The droid TW-12.7, developed by DevDroid within Ukraine's Brave One innovation ecosystem, embodies the country's approach to unmanned ground systems: practical, lethal, and immediately deployable. The platform features thermal imaging sights and night vision capabilities, allowing 24-hour operations. Equipped with anti-jamming electronics and redundant communication systems, the droid can operate in environments where Russian electronic warfare would cripple conventional drones. In one documented case, a droid TW-12.7 held a strategic intersection solo for 45 consecutive days, conducting daily duty cycles that constantly suppress Russian movement attempts, according to the NC-1 Strike UGV unit commander. Russian forces made multiple attempts to destroy the system. All failed. But Ukraine's ground robot revolution extends far beyond a single platform. The Lyut Fury represents the lighter, more mobile end of the spectrum. It's a four-wheeled platform armed with a 7.62mm PKT/PKM machine guns, or heavier 12.7mm NSVTs. These systems excel in combined operations, where UGVs work alongside aerial drones to provide overlapping surveillance and fire support. In July 2025, the 3rd Assault Brigade conducted an operation using only drones and ground robots that resulted in Russian forces surrendering without Ukrainian casualties, a historic first in modern warfare. But heavier platforms like the Termit showcase the trajectory of UGV development for 2026 and beyond. This track system can carry up to 660 pounds of payload across various terrain types, thanks to its low profile and improved weight distribution. The Termit's modular design allows it to be fitted with various combat modules, configured for medical evacuations to retrieve wounded soldiers from positions too dangerous for human medics, or loaded with specialized equipment for engineering missions. The Muraka takes a different approach. It prioritizes communication resilience above all else. Its multi-channel control architecture ensures that even if Russian electronic warfare takes down some of them, the bot can still do its job. Additionally, the drone has a carrying capacity of over 1,100 pounds, making it a premier battlefield supply vehicle. But beyond different models, the country's investment in UGV development showcases just how important it is for current tactics. Ukraine's government had contracted approximately $150 million in UGV procurement for just the first quarter of 2025, which is a 60-fold increase in spending from the same period of 2024. Earlier estimates suggested Ukraine would field 15,000 UGVs across all types in 2025, while a more recent analysis suggests that number might double to 30,000 in 2026. So, we've gone from a 60-fold growth in investment to doubling the production requirements. Victoria Tori Honcharuk, Director of Defense Tech at the Snake Island Institute, predicts that by the end of next year, we'll probably see UGV versus UGV engagements on the battlefield. Number 3. Long-Range Strike Systems. The Sapsan, also known as Ream-2 or Grom-2, represents the apex of Ukraine's remarkable journey from complete dependence on Western weapons to indigenous production of some of the war's most sophisticated systems. With a range of approximately 190 miles confirmed in combat tests and a speed of 5.2 Mach, the Sapsan flies faster than the US-supplied ATACMS, which tops out at Mach 3. Its 1,000-pound warhead is more than double the payload of ATACMS, giving it genuine bunker-busting capability against hardened Russian targets. Ukrainian officials claim production has reached 40 to 50 units per month, though those numbers remain difficult to independently verify. Sapsan also has a domestic version, which supposedly has more than double the effective range. At this extended range, The Sapsan could be used to strike as deep as Moscow itself. Tactically, these should offer Ukraine yet another angle of attack. Ballistic missiles follow an arcing trajectory that reaches targets at extreme speeds, leaving air defenses minimal reaction time. Military expert Andriy Kamarov suggested that Russian defenses are largely powerless against properly employed ballistic missiles, particularly when Russia's S-300 and S-400 systems are already stretched thin defending against Ukraine's expanding arsenal of cruise missiles and drones. But the Sapsan represents just one arrow in Ukraine's rapidly filling quiver. The Neptune cruise missile family has evolved from a single-role anti-ship weapon into a family of land attack systems that give Ukraine genuine strategic reach. The original R-360 Neptune, designed by Kyiv's Luch Design Bureau, famously sank Russia's Slava-class cruiser Moskva in April 2022 using 2 missiles, marking the largest warship lost in combat since World War II. That success gave Ukrainian defense officials confidence that Neptune could be adapted for land attack. By 2023, a modified variant with GPS-assisted inertial navigation and imaging infrared sensors replaced the anti-ship radar seeker, creating Ukraine's first indigenous land attack cruise missile with a range of approximately 360 kilometers or approximately 225 miles. The Long Neptune takes this concept further. Roughly 5 feet longer than the standard R-360, the Long Neptune features an expanded fuselage to accommodate additional fuel and a heavier 550-pound warhead compared to the original's 330 pounds. Ukrainian officials claimed the Long Neptune can strike targets up to 620 miles away, roughly 3.5 times the range of the standard variant and farther than Germany's Taurus cruise missile. Then there's the Palyannitsia, which represents something entirely new, a hybrid between a cruise missile and a long-range attack drone that costs less than $1 million per unit. Named after a traditional Ukrainian bread that doubles as a linguistic shibboleth to identify foreign agents, as Russians typically can't pronounce it correctly. The Palyannitsia went from initial design to combat deployment in just 18 months. The system is launched using a solid rocket booster that's jettisoned before the main turbojet engine takes over. With a cruising speed of 560 miles per hour and a range of 400 miles and potentially extending to 800 miles, the Palyannitsia carries a 220-pound payload guided by GPS and inertial navigation systems. Ukrainian Defense Minister Rustem Umerov announced in December 2024 that the Palyannitsia had entered serial production, with Lithuania committing €10 million or approximately $10 million to support manufacturing. The strategic calculus behind this indigenous missile program is stark. Western weapons like Storm Shadow, Scalp EG, and ATACMS come with restrictions, both in political limitations on targeting and in supply constraints based on Western production capacity and willingness. But with domestic weapons, Ukraine can strike any target in Russia it deems militarily necessary without seeking permission from Washington, London, or Paris. The cost advantage proves equally critical. While Ukraine keeps precise production costs classified, Defense Minister Mykola Fedorov stated that Palyannitsia costs less than $1 million, which is significantly cheaper than Western cruise missiles like Storm Shadow that run $1.5 million or more per unit. Ukrainian Reserve Colonel estimates suggest even lower costs of $50,000 to $100,000 for some systems, though this seems optimistic given the complexity involved. Even at the higher estimates, Ukraine's domestic production proves far more economical than purchasing Western equivalents. But the next revolution in Ukraine's arsenal doesn't just identify targets faster or fly farther, it fundamentally changes who, or what, makes life and death decisions on the battlefield. Number 4. AI and autonomy. Brave One, Ukraine's state-backed defense technology platform, has placed artificial intelligence at the absolute center of its 2026 strategy. With over 200 companies operating inside its ecosystem, Brave One is directly responsible for creating an entirely new category of warfare, one where machines process information at speeds that make human decision-making obsolete. Ukraine is fighting an enemy larger in manpower and resources, so maintaining a technological edge is existential. a Brave One representative explained. But this is also a race. Russia is actively developing its own AI-driven systems. AI is our strongest ally in staying ahead. The applications of AI integration weave through every domain of warfare. Autonomous target identification tools now allow drones to recognize and classify military vehicles, distinguish between civilian and military targets, and prioritize threats without human input. Optical navigation systems enable drones to navigate using visual landmarks when GPS is jammed, allowing drones to follow roads, rivers, and terrain features the way a human pilot would, but processing that information 1,000 times faster. Precision guidance modules give missiles the ability to adjust flight paths mid-course, compensating for wind, target movement, or last-second evasive maneuvers. Drone swarming is yet another example where AI makes perfect sense. Instead of individual drones operating under separate human control, swarms of dozens or hundreds of drones coordinate in real time, communicating among themselves to understand spatial positioning and operate as a collective intelligence. One human operator could control 50 drones simultaneously and launch complex attacks that overwhelm Russian air defenses through sheer numbers and coordination. To accelerate AI adoption across Ukraine's military, Brave One and the Defense Ministry launched a dedicated competition with budgets of up to $2.5 million per solution. Priority areas include autonomous drones with full mission autonomy, thermal and guidance modules for interceptor drones that can identify and track targets independently, AI systems specifically designed to counter Russian glide bombs, potentially the war's most destructive weapon, and simulation environments for training AI-enabled combat systems without risking actual hardware. The aforementioned AI arms race dimension adds urgency to Ukraine's development efforts. Russia is investing heavily in its own AI programs, with Chinese technical assistance reportedly accelerating its capabilities. The country that achieves genuine AI superiority, machines that can process battlefield information faster, target more accurately, and adapt to changing conditions more rapidly than human opponents, will possess an almost insurmountable advantage. The potential of AI in defense is enormous, Brave One stated, not only to increase the efficiency of our military operations, but to change the balance of power on the battlefield altogether. In 2026, the army that masters autonomy, real-time data, and machine-speed decision-making will define what modern warfare looks like. Ukraine intends to be this army. The ethical implications remain mostly unaddressed in Ukraine's rush to deploy these systems. Questions about autonomous weapons making lethal decisions without human oversight, the potential for AI mistakes that kill civilians, and the long-term implications of machine-driven warfare are largely set aside as Ukraine focuses on immediate survival. But the technology being developed in Ukrainian workshops and tested on Ukrainian battlefields will define 21st century warfare far beyond this conflict, whether the world is ready for those implications or not. Now, the final piece of Ukraine's 2026 arsenal doesn't rely on explosives, propellant, or even physical projectiles. It fights with light itself. Number 5. Directed energy weapons. Directed energy weapons had been just around the corner for decades, perpetually promising revolutionary capabilities while remaining frustratingly experimental. Ukraine started claiming it had taken the technology from proof of concept to battlefield operational in a matter of months. The system, named Trizub, after Ukraine's national trident symbol, represents Ukraine's answer to an economically unsustainable problem. Russia's nightly drone barrages were forcing Ukraine to expend missiles worth millions of dollars to shoot down drones that cost Russia $50,000 or less. The expense was slowly bankrupting Ukraine's air defense, even with Western support. Laser weapons promised to flip that equation. Shoot down drones for the cost of the electricity required to power the system. Based on the Trizub's confirmed 1.3-mile engagement range, defense experts estimate the system operates at approximately 50 kilowatts of power output, which is comparable to the British Dragonfire laser system, which costs less than $13 per shot to operate, according to UK Ministry of Defence estimates. Achieving that range requires stable beam control, powerful energy generation, and sophisticated targeting systems that can track and hold aim on moving aerial objects. The system must focus a concentrated beam of energy on a specific point of the target long enough to cause structural damage, either burning through control surfaces, destroying optical systems, or igniting fuel. Technical details suggest that Trizub can engage targets at ranges of about 3 miles for kinetic destruction, with optical blinding capabilities reaching out to 10 kilometers or about 6 miles. This dual capability is key here. Even if the laser can't physically destroy a drone at maximum range, it can blind its cameras and sensors, rendering it useless for reconnaissance or precision strikes. Against fiber optic FPV drones that resist electronic warfare, this optical attack capability provides one of the few effective countermeasures. Now, the cost comparison is staggering. According to developers working on the parallel Brave 1 laser project, shooting down a Shahed drone with a laser cost just a few dollars in electricity. The Brave 1 system demonstrated its potential in tests, burning a 2-centimeter hole through material from a downed Russian Shahed in just 10 seconds from over 300 feet away. Of course, there's a good reason we haven't seen the system widespread yet. Laser weapons face fundamental physics problems that no amount of engineering can fully overcome. Atmospheric absorption and reflection caused by clouds, rain, fog, or even humidity all significantly degrade laser effectiveness. The weapon can also suffer from a phenomenon called thermal blooming, which occurs when the laser beam heats surrounding air, causing it to expand and spread the beam, reducing its power at range. Fast-moving targets prove harder to engage because the laser must maintain focus on a specific point for several seconds to cause damage. A target traveling at high speed requires extremely precise tracking. Weather dependency is particularly devastating for the weapon's potential use cases. On clear nights, the Trizub could theoretically engage dozens of targets. During stormy weather or heavy cloud cover, its effectiveness plummets. Ukraine would still need conventional air defense systems as backup, meaning laser weapons supplement rather than replace traditional capabilities. Then there's the power concern. Despite the advantageous cost per shot calculus, a 50 kilowatt laser system requires substantial electrical generation, either from dedicated generators or battery banks that can deliver concentrated power on demand. The laser itself also generates tremendous heat that must be actively dissipated to prevent damage to the weapon's optics and components. The Trizub remains in field trials, with limited deployment to assess real-world performance. Ukraine hasn't released information about how many systems exist, where they're deployed, or their actual combat record beyond general claims of successful engagements. That secrecy is justified, as revealing laser deployment locations would allow Russia to avoid those areas or specifically target the systems with long-range strikes. But it makes independent verification impossible, leaving Western observers to assess Ukraine's claims based on technical plausibility and the country's track record of delivering on ambitious weapons programs. If the Trizub and Brave 1 lasers prove operationally effective through 2026, expect them to be deployed nearly immediately. Ukraine has demonstrated its ability to take successful prototypes to mass production with remarkable speed, and laser weapons should, in theory, be easier to manufacture than missiles or drones. The components are largely commercial: high-powered laser diodes, advanced optics, tracking systems adapted from existing platforms, and power management electronics. Ukraine's growing defense industrial base could potentially churn out dozens of laser systems monthly once production lines are established. And the real revolution may not be the lasers themselves, but what they enable. If Ukraine can effectively neutralize Russia's drone threat at negligible cost per engagement, it frees up expensive surface-to-air missiles for more valuable targets, such as Russian aircraft, cruise missiles, and ballistic missiles that lasers can't yet defeat. That reallocation of defensive resources could prove as strategically significant as any offensive weapon system, allowing Ukraine to maintain air defense coverage while conserving ammunition that's increasingly difficult to procure. So, where does this leave us in 2026? 4 years before, Ukraine was fighting Russia's invasion with Soviet-era weapons and desperate improvisation. By 2026, it's fielding weapons that were just a few years ago considered science fiction. Russia's generals are watching these systems deployed against their forces in real time, and they understand the implications. It's clear that Ukraine is no longer in purely survival mode. Yes, it's fighting for its existence, but it's also innovating faster than Russia can adapt. Every month brings new Ukrainian weapons that Russia's Soviet-era military doctrine has no answer for. The 3-day special military operation that was supposed to decapitate Ukraine's government has instead created a crucible that's forging the most technologically advanced battlefield military on Earth. And here's what should terrify Russian planners most. These 2026 weapons are technically old news by the time we learn more about them. Considering that Ukraine has all the reasons to keep its most ambitious and effective systems under wraps, we'll likely see even more developments throughout 2026 and beyond. The weapons Ukraine fields in 2026 will define how wars are fought for the next generation. NATO is taking notes, China is taking notes, and Russia is desperately trying to figure out how to counter systems that didn't exist 3 years ago, developed by a country they assumed they'd conquered by now. Welcome to the future of warfare. Ukraine wrote the manual. Thanks for watching. Now, if you want to learn more about how this war has affected Russia, check out this video and stay tuned to the Military Show for more analyses and the latest defense news.